Our next topic is all about acids and bases. An acid is found in vinegar and also in lemon juice. Bases, they are found in soaps and also detergents. Acids, they taste sour. Bases, they taste bitter. There are a lot of differences between the two. Just check your book for more differences. Let's now go to the definition of acids and bases. So these definitions, they try to explain what happens to the particles of acids and bases when they react with other substances. The first definition comes from Arrhenius. He suggested that an acid is any substance that produces or increases the concentration of hydrogen ions when dissolved in water, while a base, they produces or they increases the concentration of OH or hydroxide ions when dissolved in water. Also, we have the Bronsted-Lowry Theory, which states that an acid is any substance that donates proton. Meanwhile, a base is any substance that can accept protons. So these two definitions differ in terms of their perspective. The Arrhenius theory, this focuses on the concentration of hydrogen ions than hydroxide ions. On the other hand, the Bronsted-Lowry theory or idea, this focuses on the donation and then the acceptance of protons between different substances in a solution. So it's almost the same because here we have an acid, they donate protons. So these protons can also be viewed as an H plus ion because of course an H plus or a hydrogen, as we go back to our basics, so a hydrogen is composed of one proton and also one electron, and on this case it becomes an ion, so it becomes positive, so it means that this electron is lost from this atom. So what's left in an H plus ion is a proton. So again, this proton can also be viewed as an H plus ion. So in this case, the acid also discusses the um, increase on the concentration of hydrogen ions or proton in the solution. Okay, let's analyze this one. So we have here hydrochloric acid reacts with water. It forms the following. So in this case, when we dissolve HCl in a solution, especially with water, so this HCl actually dissociates into ions. So this separates into H plus and this becomes Cl minus. So as you see here, this increases the concentration of hydrogen ions when dissolved in water. So this one is an acid based on the Arrhenius definition. Again, an acid, according to Arrhenius, they produces or increases hydrogen ions when dissolved in water. So this H plus ions, they comes from the uh, this comes from the dissociation of the acid. So they break into ions, H plus then Cl minus. Then this H plus can be observed. So there's an increase on the concentration of H plus in the solution. So as you see here, this H plus is positive. So it will not stay freely in the solution because it's positive. It will be attracted by a negative particle, especially by an H2O molecule. As you know, oxygen is much more electronegative, so this H plus will be captured by this H2O molecule, forming an H3O plus molecule or a hydronium ion. So we can also uh, see that an acid also, it also increases the concentration of H3O plus in the solution. So again, this H3O plus comes from the H plus ions that is captured by an H2O molecule. Then also if we look back here, so this H plus from HCl, this one is captured by H2O, so we can also see this one as an HCl donating its proton or H plus to the H2O molecule. So in this case, again, this HCl, it donates its proton. Again, this H plus, this one is a proton. So it donates its proton towards H2O molecule. So this one is an acid according to Bronsted-Lowry, and also this H2O molecule, since it accepts the proton, this is our base on this case. So we have this one is a base, then this one is our acid. Okay, so again, on this case, HCl is an acid. On the other hand, it will be a base according to the Bronsted-Lowry. So again, this one is a base because it will accept the hydrogen from HCl. So of course, H plus H2O, it will become H3O plus. Then of course, this Cl will be here. So this one is the reaction of an acid with any substance in a solution. Now let's observe this one. So it can also go in the reverse direction. So on the reverse reaction, so this H3O also, it can also donate. Let me erase this one. So this H3O, this can also donate its, okay, so again, these are the products. On this case, we have H3O plus and also we have Cl minus. So this H3O plus, it can also donate its hydrogen towards chlorine because of course it's also negative. So in this case, again, this H plus from H3O, it can donate its um, H plus or proton to Cl, forming of course HCl. So in this case, if we go on to the reverse reaction, this becomes an acid, and also this becomes a base if we go on to the reverse reaction. So here we have the concept of conjugate acids, then conjugate base. Again, this one is the acid, then this one is the base. Then also on the reverse reaction, this H3O plus can also be an acid by donating its H to Cl minus, forming HCl. So this one is actually our conjugate. This one is our conjugate acid. Then this one is our conjugate base. Conjugate base because it will accept the H plus or the proton from the H3O or the hydronium ion. So in this case again, so we have the acid, then this one is the conjugate base, then we have this base, it partners with a conjugate acid. So this one is also part of the Bronsted-Lowry theory. This introduces the concept of conjugate acid and also the conjugate base. Let's observe another one. We have here ammonia mixed with H2O or water. Then this forms the following. Okay, so on this case, as you see here, so this NH3, so this will actually from NH3 to NH4, meaning it accepted one H plus, and on this case the H plus comes from the H2O molecule on this case. On this case, so diba, it's composed of that's H2O, okay, H2O, you have your NH3, hydrogen, hydrogen, hydrogen. So in this case, this becomes NH4 plus, so meaning it captured one of the hydrogen from here. So okay, that's hydrogen. So then H2O, what's left is the OH minus on this case. So as you observe here, this NH3, this accepts, right? So this accepts the H plus, or again the proton. Again, H plus here is the same with a proton. So in this case, this one accepts the proton, then si H2O siya ang nag-donate sa proton. So in this case, siya si base. Sorry, it's the acid on this case. This one is the acid on this case. Let me just rewrite this one. Again, so this H plus, it donates its proton towards NH3. So in this case again, acceptor, this one is the base. So ammonia or NH3 is a base. Meanwhile, on this case, H2O acts as an acid, donating its proton towards the base. Then again, also on so if you consider the reverse reaction, so we have your NH3. So on the reverse also, so this NH4, it can donate its one hydrogen to OH, forming H2O. So on this case, this one is an acid, this one is the base, again this one is the conjugate acid, conjugate acid, conjugate base, okay, conjugate base, and again this is partner, base, partners with a conjugate acid, then we have this acid partners with a conjugate base. Okay, so again that's the difference between an acid and then a base. So as you see here, so on this case, this one again is an acid, this one is a base. Then on this reaction, this one is a base and this one is an acid. So as you see here, H2O can be a base or it can be an acid. So on this case, we call H2O as amphoteric. So amphoteric substances, they can be acid or a base. So diba, on this case, on this first reaction, this H2O acts as a base, accepting the proton from HCl. Then on this case, it acts as an acid, donating a proton to the base. Again, so we call this one as an amphoteric. So they can be acid or base depending on the reaction. So here we have two molecules of H2O, so we can also see here that an H2O can react with other H2O molecule to form hydronium then OH minus. So on this case, we call this one as autoionization. It's autoionization because it's the same substance, diba? It's H2O, H2O, and then they form ions. So we have H3O plus then OH minus. So this one is the autoionization of water. In pure water, the concentration of H plus is 1.0 times 10 to the power of negative 7 molar, and the concentration of OH minus ions is 1.0 times 10 to the power of negative 7 molar. So on this case, equal ang number sa hydronium then C, then sa OH minus. So remember that pagtaas ang OH minus, it means this one is a base. Then pag mas taas si H3O or we have H plus, diba? So again, this is the same H3O plus, then H plus, this one is an acid. So in this case, since equal ang concentration ni H plus and then equal ang concentration ni OH minus, then this one is neutral. Then this one must be neutral.